This is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. Today, we are going to discuss a topic called as different methods of study of minerals. So, in this topic today, we are going to discuss about there are different methods, how we are going to identify the types of minerals, how we are going to identify the physical properties of minerals. So, there are different methods to understand for identification of different kinds of minerals or rocks. If you want to identify, we can just understanding these topics. So today we'll be discussing this topic today. So first of all, let us understand what are the methods or in what way we can just try to identify the types of minerals so that we can just easily get to know the different presence of minerals in their properties and their composition and their occurrence in the nature. So, as per this topic we are going to discuss today, we are having different types of methods where we can just go through and just identify the types of the mineral. So, in this mineral, we have different types of methods like physical property analysis. So, if you remember in the previous topics, we have just discussed about the how to identify the minerals. So here in one of that case, we are going to identify the mineral with the physical property analysis. So the physical property analysis is one of the method where we can just identify the mineral properties. Suppose, for example, in the physical property analysis, determines the scratch resistance or luster, examines how light interacts with the surface and the metallic vitreous or non-metallic feature. So that we are all going to understand based on the this physical property analysis. So we have different kinds of more methods under the physical property analysis is color and streak. So if you remember in the previous lectures also, we have just learned about the properties of minerals to identify with the help of their texture, their color, their streak, their appearance, or their occurrence. So like that, when you talk about the physical property of a mineral, so we are going to discuss about the color and streak also. So color of the mineral versus the color of its powdered form. So what does it mean by the streak is, so in this identification, once you make the mineral in the form of a powder, so as the mineral appearances color is yellow color, the powder form may be in the white color. So streak is basically about when you make it in the powder form, how does it looks like? So that is called as a streak. And cleavage and fracture, how a mineral breaks. So whenever a mineral you try to break it off, then it can break as a plane surface, it can break as a fracture surface. So fracture in sense, it will be very irregular shape, it will be. But when you talk about the cleavage here, so cleavage means the breakage of the mineral will be very smooth surface where we can just identify the flat surfaces at the time of the breakage. Whereas the fracture here is about when you break the mineral, it will be an uneven kind of breakage, like it looks like a up and down kind of fracture. Some places it looks plain, some places it looks very rough texture. So that kind of appearance we call it as fracture. So how a mineral breaks along the planes or irregularly, that is called as cleavage and fracture. Now next is specific gravity. So measures density relative to water. It measures the density and relative to the water. The specific gravity is basically about the relative to the water. Now if you talk about the physical property here again, it analysis involves evaluating the fundamental characteristics. It understands the fundamental characteristics of the material that define their behavior and understand the different conditions. So how do you define the behavior and the different conditions here is, for example, we have in soil rock classification for a geotechnical engineering and geological application, physical property analysis helps to determine the sustainability of the soils and the rocks. So for the construction and for the other uses, for the common properties, it includes like density and unit weight. When you talk about the physical property, so it includes like a density and unit weight. And before, what you have seen is streak as well as cleavage, fracture, specific gravity. Along with this, when you try to identify the soil and the rock classification, so here we can just identify through density and unit weight. So mass per unit volume, like a dry bulk and the saturated condition of the particular rock or mineral. And you talk about porosity. Porosity is the percentage of the voids. So voids are the spaces, the gaps which are present in the material. Now permeability is the ability to transmit fluids, importance for the groundwater flow and drainage. So grain size distribution, so it determines the soil classification, sand and silt clay. Now next thing is optical microscopy. So this is another method how you can just you can study the types of the minerals which are present in the nature. So optical microscopy is one more method, we call it as spectrography. So it is called as spectrography. So spectrography is a optical microscopy is a widely used technique. It's a widely used technique for analyzing the microstructure and the physical properties of the material. So it is widely used technique. It is a technique for where you analyze the microstructure. When the mineral is having a microstructure and the physical properties of the materials, it usually utilizes the visible light. Like we can just utilize the visible light, which is called as the in a spectra. If you see the visible light means through where you can see the 7 colors, that visible light and a system of the lenses to magnify the small features, typically up to 2000x magnification. So it is up to 2000x magnification. So thin section microscopy. What is thin section section microscopy? Here is using a polarizing microscope. So here when you talk about the optical microscopy, we use a microscope which we call it as polarizing microscope to study the mineral properties in this slices of rock. So using a polarizing microscope to study the mineral properties in the thin slice of a rock or a refractive index, which determines how light bends in a mineral using a refractometer. So this is one more method how we can identify the type of the mineral with the help of the visible light with a magnification of 2000x magnification, where we use a polarizing microscope. And this polarizing microscope where you can use the rock or mineral in a powder form. So the mineral and the rock will be we use the streak or we use the powder of the mineral and we keep in the lens to identify the properties of the minerals. So once you keep under the microscope, you can just identify the different kinds of minerals present in that and their color, their appearance, the metallic and non-metallic structures and all. We can do with the help of the optical microscope or optical microscopy. We call it as spectrography. Now we have the third method here. Third method is about the X-ray diffraction. So this is one more method when you identify or you study about the mineral. So we can use even this method to just identify the study of the mineral. Like X-ray diffraction is a powerful analytical technique. It's a powerful analytical technique and it is used to determine the crystallographic structure. So X-ray diffraction is a powerful analytic technique and which determines the crystallographic structure, phase, composition and the physical properties of the materials. And it is widely used in the geology, material science, engineering and for the analyzing the crystalline substances, which we can analyze the crystalline substances as minerals, metals, ceramics and the polymers are concerned here. So this kind of method like X-ray diffraction is a kind of method where we use the analytic technique and where we determine the crystalline or crystallography structure and the composition for a physical property of the material, and it is widely used in geology, material science, engineering, analyzing the crystalline substances as a mineral, metals or ceramics and a polymers. So it identifies the mineral structure by analyzing how X-rays scatter through a crystalline sample. Now, fourth method here, there's one more method here, we call it a scanning electron microscopy. Scanning electron microscopy. So this is one of the method where we use, and it provides a like a scanning technique we use, and it provides a high resolution imaging of mineral surfaces and composition using the electron beams. So here we use electron beams to identify with a high resolution image. We try to identify the composition and the mineral surface by using the electron beams. And scanning electron microscopy is a high resolution imaging technique used to examine the surface morphology, the mineral surface morphology, and the microstructure of the mineral and the composition of the mineral at a nanoscale. It provides detailed insights into the physical and the chemical properties of material across the various fields, including the geology, material science, structural engineering, and nanotechnology. Now, there is another method, we call it as X-ray fluorescence. So these are all methods which are generally when we go with the very microscopic study of the mineral, then we go with this all kind of methods. Generally, we go with the physical kind of method, but if you are going to do the detailed study, then you have to go with this X-ray fluorescence or microscopy, or we can use the scanning electron microscopy methods. So determine the elemental composition by the measuring fluorescence emitted from a sample when exposed to the X-ray. So now here in this technology, here in this method, what we do is elemental composition by measuring its elemental composition by measuring the fluorescence emitted from a sample where exposed to, whenever it is exposed, a sample which is exposed to the X-ray, that determines the elemental composition of the mineral. Now, X-ray fluorescence is a powerful analytic technique used to determine the elemental composition of solid. It can determine the solid, it can determine the liquid, it can determine the powder materials. Powder material is the material what we call it as a streak. Okay, streak. So the mineral which is in the powdered form. Okay, powdered form, that we call it as streak here. So whatever mineral which is in the powder form, that can be identified with this help of this X-ray fluorescence. Now it is widely applied in geology, material science, structural engineering, and environmental analysis for non-destructive chemical analysis of the materials. Now the sixth method here is electron microprobe analysis. When focused electron beams to analyze mineral composition at microscopic levels, like electron microprobe is an analysis also known as electron probe. Macroanalysis is a high precision technique. This is a high precision technique used to determine the elemental composition. So what are the elements which are present in that particular mineral? So it will help us to determine the elemental composition of a solid material and a microscale. And it is widely applied in geology. Material science, metallurgy, and engineering for analyzing fine scale chemical variations in minerals, metals, ceramics, and the synthetic materials. Infrared spectroscopy. So it analyzes how minerals absorb infrared light to determine molecular composition. Infrared spectroscopy is a technique used to identify and analyze the molecular composition and chemical bonds of a material based on its absorption of infrared light. Now, it is widely applied in the geology, material science, structural engineering, chemistry for studying the organic and inorganic compounds in solid, liquid, and gaseous state. Now, there is one more method here. Basically, we use it here, field techniques. So, field techniques is one of the important methods here where we use it generally observing the minerals directly in the fields. So this is also kind of a physical method where we go to the field and we just directly see the mineral physically, and we try to identify the property of the mineral, right, or the study of the mineral. Now we have geochemical assays, like a chemical test to determine the mineral content in the sample, like a chemical test we do to determine the content, what are the different contents which are present in the mineral. So we just process this geochemical assays, and field techniques are essential for the on-site material. So these are the techniques which are essential for the on-site material characterization. So in the field technique, whenever you go to the site, directly on the site itself, the material composition, the material characterization, particularly in the geology and the construction and the environmental science and the engineering fields. So this kind of technique, we use it for the identification of the type of the mineral present in that, right? So these methods allow rapid, non-destructive and the cost-effective. This is because it's a field technique. So it is like immediately when you go to the field without any kind of method or any kind of laboratory or any kind of instrument, directly we go to the field and rapidly we just get to know the information about the minerals. And it's a non-destructive. First of all, rapid means very fastly we try to get the information. Non-destructive means there is no tools and techniques we use it for any kind of destruction. We don't use for the identification of the mineral. And the third thing, it is cost effective. Cost effective, like there is no cost here to identify the mineral, whereas compared to this field techniques, when you go with the X-ray and the stereoscopy or any kind of spectroscopy, there we need different kinds of machines or tools, and it's very costly compared to this field technique. So here field technique is very cost effective. Easily and rapidly we can just get to know the information about the mineral. Assessment of the soil, rock, structural materials and the environmental conditions without the need for the laboratory analysis. So here, because it is a direct field technique, so here we don't need any lab or we don't need any analysis to identify the physical property of the mineral here, right? So this was about the different methods of the study of the mineral. So compared to this, all the techniques what we have seen here, so this field technique is the very cost effective technique, whereas infrared spectroscopy means we need an instrument here to determine the composition. Like electron micro also we need an instrument to determine the composition. X-ray fluorescence also, it's a very costly kind of method where we go with the study. Scanning electron also, it comes under the costly. X-ray diffraction. So basically what we do is we use either this physical property analysis, either we use this optical microscopy, and finally we use this field technique, which is the easiest technique and the very useful technique and very effective technique with a very less cost. So these are the different techniques how you can just go and identify the mineral properties and their composition. So these are the few of the references you can just go through to find out more content about this topic, where you can just go and get more information. So like Keshav Blue and Chinna and Venkat Reddy or Vasudev Keniti or F.G. Bell, Fundamental of Engineering Geology, which you go through to find out more content about it. So that's all for today's lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.